Well, we're heading over to Garage Mahal.
Right.
Last week we were laying track
Yes.
because with the virus and everything, and so we're actually getting a lot done on the railroad. Anyway, this week we're going to be casting components for the track.
I'm worried.
We showed you guys a couple years ago the casting equipment over there without showing you how molds are made or anything. So we're going to go through that whole process because we need tie plates and point slide plates and that kind of stuff. So we're going to be making a mold to cast those things and then casting a whole bunch of track components. So this should be fun.
I'm really enjoying working on the layout.
And I love what you're doing with the backdrop.
Oh my.
You know, we're having a lot of fun.
That's the main thing.
That's the key, and it's kind of a strange time right now, but we're sure making a lot of fun out of it.
Well, and it keeps my mind busy.
Well, yeah, it's much better than sitting around moping. Now, last week I was laying some track on the very back track, and if you remember, I wasn't using tie plates, in part because it's very difficult to reach back here. But I always wanted to use tie plates on the railroad, but just not absolutely everywhere. Now, most of these tie plates I've just bought from Micro Engineering, but this week I'm going to cast a few.
What the heck?
Rio Grande track.
Oh!
It isn't always in the best shape, is it?
No.
And you can see here there's two tie plates, then no tie plate, then a tie plate, then no tie plate. It seems that the Rio Grande was pretty hit and miss about where and when they used tie plates. So on the railroad, I don't feel obliged to doing tie plates and all kinds of things everywhere. On the back track, I haven't used any tie plates, in large part because I can't reach back here very well.
No.
Now, I'm getting my ties from a guy named Warren James. He sells them on eBay, and then I don't have to worry about cutting them. I'm also buying a lot of my track components from Logos Creek Railways, Mike over at Logos Creek. And he has these various castings, in this case, frogs and points.
Oh, that's Jim Harper's railroad in St. George.
You know, he's got the best track work I've ever seen on any model railroad, and by a factor.
Oh, I'll say.
It's just beautiful. Look at this beautiful three-way switch, but everything is in tie plates. And look at his switches. He's put in point slide rail braces, or chairs, as they're sometimes called. I mean, that's just a detail you don't often see. And look how neat that looks.
Wow.
I love that railroad. Anyway, Mike over at Logos Creek used to sell a point slide rail brace cast out of nickel for $2.50 a piece. So they really add up because you need 10 of them to lay a switch. But moreover, he doesn't make them anymore. So I've decided I'm going to have to cast my own. And that's what we're going to be doing. Also casting some other parts. But this was the principal motivation right here, to cast a bunch of these based on Mike's part. Here we can see some of Mike's parts installed actually under one of Mike's switches. I'm just test fitting them here to see how the whole thing's going to go together once I cast my own pieces. And you can see how those install. So here we can see a pile of Mike's nickel silver rail braces that I've cleaned up and got ready to make a mold off of. And what I'm after is this other pile over here. This is what I'm going to be making, the same exact thing based on those parts, but cast out of white metal. They should still work fine, even though they're much softer and flimsier than the nickel silver. So here's how the whole process begins. This is unvulcanized rubber mold halves that I get from Romanoff rubber. And these are acorn nuts that are used to hold the two halves in registration. And this is my Spru gate and some mold release, all stuff I'm going to need. And this is the mold frame. The rubber goes in here and then is pressurized and vulcanized. So first I'm going to make sure the frame is closed at the bottom. The bottom comes off for releasing the mold, but I have to make sure it's on there really tight before I actually make a mold. And then I'm ready to put the bottom half of the mold into the mold frame and start building up my mold. Now I'm putting some talc in here as a mold release. I put a lot of different kinds of mold release. I do not want the two halves to get stuck together. And this talc will absolutely ensure that that doesn't happen. And then I'm going to place my sprue former in the very center. That'll keep some sprues there so that the metal can flow out in the direction of the parts, but not right up to the parts. Next, I surround the outside edge with acorn nuts, kind of randomly spaced, and that will hold the mold in registration for the actual casting. And now I put my sprue former in here and start marking out where the parts actually need to go into the mold. And here I am putting the rail braces in there. You can see I'm putting them in upside down. I've cut a little slice there with a knife, and that helps hold them in place, but it will also allow gravity to help the metal flow into the parts more readily. And there it is. Now I had some space down at the bottom, so I've just put some tie plates down there. I can always use some more tie plates. So now every time I run the mold, I'll end up with about 10 tie plates as well. And now to close up the mold very carefully, because if I jostle this, I might move the parts around inside and undo all the work I've done up to this point. So I have to be very careful to bring this straight down on top of the parts without disturbing anything. And then I can put the top onto the mold frame and put the entire mold frame into the mold press, which I am preheating to 350 degrees, and that will vulcanize the rubber, make it into nice hard rubber, just like a car tire. I can close these two plates together with the bottle jack below, and that will put, well, actually several thousand pounds of force across the soft rubber as it vulcanizes, making sure that all of the parts inside take a really good mold and nice and clean. No bubble spaces or voids of any kind. So I very carefully work the bottle jack and bring it up to about, I don't know, 4,000 pounds of pressure, something like that, and then bake the mold for 1 hour at 350 degrees.
Our souffle is ready.
Yeah! 350 degrees for 1 hour.
Yeah.
Good for souffle, or in this case, a rubber mold. Now I'm going to open the frame outside because as I open this, it releases quite a stink, frankly. The vulcanized rubber, well, we all know what burning rubber smells like. And if you do this indoors, you'll really regret it. So I've hauled it out here so that when this thing opens and a huge cloud of vapor comes out of it, it doesn't asphyxiate us.
Probably preferable.
Oh, there it is. Ooh, a little puff of smoke, a little brimstone.
That's why you opened it outside.
Yeah, it smells just like tires now. Boink. Hey, look at that.
Get it off the lawn before it burns the lawn.
Yeah, I was going to say you just sauteed the lawn right there.
There it is.
Oh, wow. Look at that. And smoke. Hey, look at that.
Well, it's a really successful mold. I can see where all the little mold cavities are absolutely perfectly clean and clear. And as I pry the various patterns out of here, the original parts, I can see that it's a really, really clean and perfect mold. And boy, is it putting up a stink. We need to get it back outside.
Jeez.
That's a really good pattern.
Yeah, it is.
Smells like the inside of a tire shop.
Which is a weird but not terribly unpleasant smell.
It's not unpleasant, but weird.
They cool off pretty fast.
Well, at any rate, I now need to get the remaining patterns and bits and pieces out of the mold, and then I can start the long, slow, and somewhat difficult process of cutting gates from my sprue former over to the actual parts, and that'll carry the molten metal out from the center of the mold and into the actual mold cavities. And the trick there is to allow the metal in without creating a gate that destroys the part. Fortunately, the patterns cool off very rapidly. They're quite small, and once they're out of the mold in about 30 seconds, they're quite cool to the touch.
This is a job for needle nose pliers.
Yes.
That's hot. It's burning my glove.
Yeah.
And these little metal pieces, being metal, and being small, within seconds of coming out, they're just room temperature.
Isn't that weird?
Yeah. They cool off so fast.
Well, depending on the metal too, like aluminum cools really fast too.
Well, the stuff that they do white metal, the only reason that it works at all to cast metal in a rubber mold is because it cools so rapidly.
Ah.
Otherwise, it just burn right through. If you were to put brass or something in there,
Oh, yeah.
that'd be the end of it. But these white metals crystallize and cool so fast that they
That
hit the
leaves
rubber
no
and they
pressure.
just turn back into solid metal.
Wow. What's that
That's
one?
still pretty warm. That's the Spru former,
Okay.
and it's a really light metal. Still got a little heat to it, but not much.
Yeah.
But I can just feel
Yeah,
the heat
that.
pouring
What's
off
that
of
made
it.
out of? Like cast? Or is
It's machined, yeah, mild
Iron?
steel,
Okay.
and they cost a fortune
Yeah.
because that's all got to be hand machined.
Right.
You just call up a machinist and you say,
I need this.
I need one of those, and they say
brake
that's going to
drum.
cost you $500. And there you go.
Anyway, we are now ready to start cutting the gates from the sprue former over to the actual parts to bring the metal over there. Now, the knife I'm using is not my first pick at a knife, but you use needle nose pliers and a very, very sharp knife, and you just cut these little channels all the way from the part over to the sprue former. And the tricky part here is right where the sprue attaches to the part, the gate that's going to allow the metal in. Because if you make that too big, you'll never be able to separate the part, or you run the risk of actually cutting into the mold part and ruining the part that way. So it's a fairly delicate operation. And then the mold is going to be brought over here to the casting machine, and the molten white metal shot into that mold. Now my partometer here is all screwed up. It says I'm running at 400 degrees. I'm actually somewhere up around 700 degrees here, but I'm used to the fact that my thermometer is all wrong. So some more talcum powder for a mold release, and I should be ready to spin my mold and shoot some metal into it.
There we go.
Let's see.
Oh, pew. It stinks.
Except for a really long run. I don't need it.
Boy, I'm glad this thing stops as quick as it does.
Yeah, I accidentally got tangled up in it one day.
Oh, seriously, no.
I thought I'd broken my arm, no lie.
Oh.
So it's, equipment. Equipment can be really dangerous.
Oh, gee, yeah.
Yeah. Look at that. Woohoo! Look at that. Perfect.
They look really good.
They turned out perfect.
They did.
I was surprised usually the first time you run a mold, half the things don't actually cast. But in this case, every single part came in perfectly
Nice.
on the first throw.
Wow.
Very rare. Now we just need to get them broken off the trees without actually breaking the parts. And then we can start accumulating parts to use on the railroad.
Oh, those are really nice. I have a little cleanup work to do on them, but not bad.
Not bad at all.
Molten yikes. Start over again. Anyway, that many. Woohoo! Fun. That's neat how that works.
Isn't that cool?
And so there we are, a success. Here we have again the nickel silver chairs or point slide rail braces and my recreation. Now you'll notice that my castings here are a little tiny bit shorter and surprisingly a little tiny bit wider. Well, that's because the metal was heated up to 700 degrees, and so of course it's much smaller once it cools off. But the wider thing, I guess that's just because rubber is rubber and strange things can happen when you cast things in rubber molds. So while we were at it, we ran this other mold that's just got a bunch of oddball things in it.
I see a switch stand. Is that the one you're going to use, or?
Well, this one's just going to be decorative. I want to use a different one on the railroad. The switch stands that I'm actually going to be using on the railroad are made by Mike over at Logos Creek, and they're these great little kits. You get the whole kit for $25, and they're just so finely detailed, but the key is they're really strong and they will function. And then also you can see that in my white metal mold I've cast a bunch of switch lanterns, and I'm going to mount those on Mike's switch stands. So look how quick we build up all this cool stuff.
Isn't that fun?
I love this process. It's just fun making a mold and then casting a bunch of parts. So anyway, that's how you make a mold. And cut the mold and go through all those processes. But the key thing is we're going to use these components that we've cast this week to lay switches next week. So that should be fun. Anyway, if you haven't been over to the channel, pop on over to the channel. And if you're not a subscriber, here comes the blue button. Are we ready for it? Zoink! Right there, the blue button. Well, we're not sure how you found this video on the internet. We hope you didn't find it boring. And we will see you on Tuesday with some stuff. And then on Sunday, we'll be laying switches. See ya. Bye-bye.